about to start as well. All right, we're going to get started. Good morning. Welcome to the Residential Energy Codes and Standards, the new future of new construction in California. Please silence your cell phones if you haven't already. The session is going to be about an hour long. We'll spend about 35 minutes on presentations, and we'll allow about half the time for questions afterwards. When the question and answer period is open, please raise your hand and wait until the mic runner comes to you, because people are listening online and watching online. We want to make sure that they hear what your question is. And we ask you that you limit that time to questions and rather than commentary on the presenter remarks. We're going to start with Chris Meyer from the California Energy Commission. He's the manager of the Building Standards Office at the Energy Commission. And his background is in environmental and engineering aspects of large construction projects and project management. His most recent large project was to shepherd the 2019 California Building Efficiency Code changes through, the code update through. And he's still recovering from that experience, but he's going to give us a background on that session, on that activity, and the background on the codes and how emerging technologies fit into those codes. And then we'll follow his talk with Martha Brooke, who's the policy advisor at the Energy Commission on the future of codes and standards. And then finally, Ed Minster will be talking to us about the real world of implementation. So Chris, if you join us, and Martha and if you want to keep your heads out of the slides, maybe you can just drop down to the table and then come back up. Thank you. Chris, this is already great.
Great. Thank you, David. Christopher Meyer, Building Standards Office, the Energy Commission. And I will sort of float around at this until I figure out the right buttons to hit. So, there we go. Yep, we're good. So, as a lot of you know, since you're sort of emerging technologies, leading can be sort of like being the first person on a group of trail runners. You find all the holes and the low branches. So this has been an interesting cycle. We've found all the people who don't like our ideas, but it's been informative even in our missteps. We've learned a lot. So basically, as a lot of you know, it's like there's the policy drivers for where we went in the 2019 cycle, focusing on residential photovoltaic requirements. That a lot of it came from the goals about 10 years ago to have a residential ZNE by 2020 and then by 2030 get non-residential ZNE. We learned very early in working with stakeholders from the utilities, from builders, from Cal ISO, PUC, that the original idea of ZNE, where you were basically think of it as an accounting exercise of having a much larger PV system to offset all of your energy from gas as well, ended up with overgeneration issues. So we very quickly shifted to thinking of just offsetting the electrical consumption of the house. So, if you needed 6,000 kilowatt hours, that's what you were producing from your PV system rather than created an overgeneration issue. So, and more recently, 3232 is looking towards a future of shifting focus towards zero emission buildings. So, one of the big things that we come back to all the time in our standards is they have to be cost effective. And you'll see that certain measures are only in certain climate zones, California being a very diverse climate. There are some measures that only work in the Central Valley that give you no real benefit. You're not going to put a whole house fan in the desert if it's still 100 degrees in the middle of the night. You're not going to get any benefit. So we don't want people to trade off for something. So we have to look at all the different climate zones. We want to make sure that anything we require in the house is going to have a benefit to that owner of that building, owner of that house, that exceeds the initial cost of that investment. So just really quickly going through sort of what we focused on non-residential, we updated the lighting. Going to that LED baseline was a huge savings in energy and standards. And we also changed the measures for outdoor lighting. That was a big concern for some people. We went to a 3,000 Kelvin light limit, and some people were concerned about that. But when you saw a lot of the existing lights out there were, at a 2,200 color temperature and a color rendering index of 20, going to 3,000 and color rendering index of 80 was a huge improvement, also a huge benefit in energy consumption as well. So the residential standards, as I said, one of the big things actually, before I go to the PV, one of the big things we did was air quality. ARB has been pushing for a long time on getting better indoor air quality, and as we've tightened the envelope up, people have tight houses with not a lot of air coming in, so the indoor air quality can get bad if you're not running your system, if you don't have the right filters. The old filters would filter out PM10. The new filters, the MER13, they'll go down to PM2.5. So both indoor air quality issues from cooking, other sources, outdoor from vehicles and other pollution, this will address them. And we basically found that there are MER13 filters on the market, a vast majority from 3M, the ones you see most likely at Home Depot, Lowe's, places that people could easily get them, that have the same pressure drop as a MER6. So you're not actually changing your systems at all. The same system is going to run these. You actually have more of an issue with a pressure drop if the electrician kicks the filter or kicks the duct out of the way when he's doing something and doesn't repair it. So this is the big one that I was talking about is for the first time we required a PV system on residential low-rise. And again, we're basically focusing on just getting an electric generation system that is equal to your annual load. So it's a small system. These are averaging throughout the state at about 2.8 kilowatts. These are small systems. One of the big reasons is in 2016, the envelope and other efficiency measures were getting good enough so that the energy consumption in these houses is very low. So you might see a 6 or 8 kilowatt system on a retrofit, and 2.83 on a new building. So that's how much better the buildings have gotten. So that's one of the big things. Another big one going towards the sort of carbon future is we worked a lot on water heating to make sure that we got rid of as many barriers to heat pumps, heat pump water heaters, electric heat pump water heaters, so that they could comply in new construction. So, just very quickly, just the path of the future is we're going to always have the necessity of looking at cost effectiveness. We're also, in the back of mind, we're looking at how everything we do, if we have two different measures that are going to have equal energy benefit, cost benefit, if one of them has a better ability to deal with GHG reduction goals or deal with energy savings during the utility peak, that's generally where we're going to focus our energy. So we did a lot of work in this last cycle of work with utilities and PUC to figure out how the houses work with the grid and how to make sure that nothing we did with energy efficiency standards had adverse effects to the grid that could result in needs for infrastructure upgrades and could have socialized costs of the rates, at the PUC. So we basically, I promised the PUC very early on that we would not run across the finish line going, well, hey, we made it, and then hand them a horrible problem. So anyway, as we talked about this, we put the standards up there, we looked at, put the exceptions in for shading and other things. We don't want people to cut down heritage oaks or nice trees that are shading the building, just put a PV system up there. So we looked at that. We also wanted to make sure that there were exceptions. If it's a tall building, mainly, if it has other mechanicals on the roof that limits it. So that's one thing. We also had a lot of interveners and a lot of stakeholders who really wanted us to have a community solar option. We were working on that. We put a provision in there that if people came to us with a community solar option that had the same benefits to the homeowner as PV on their roof from a cost standpoint, we would definitely consider that. So we gave it a way to do it, but we're still working on getting a community solar program that fits that bill. Going towards that carbon, focus in the future. One of the things we added to CVEC, a lot of you are probably familiar with this, is our modeling software, is we added a tab on carbon emissions. So this way, everyone's been focusing in the past on cost effectiveness. They've been focusing on the benefits to the homeowner, how to sort of say we want efficiency, not conservation. We want to give you the same benefits with less energy. How can you make decisions either at a local level or at an individual level, saying I want a house that meets Title 24 but is also low carbon. And we gave the opportunity to say, okay, play around with different designs in the building, different mechanical systems, and see how that impacts your carbon in your building. What we did find is that adding the PV and reach codes and the sort, adding batteries, things of that nature, they went really far into reducing the carbon intensity of the building. This gives you sort of an idea of 2,000 compliant building, no PV, with 6.5 tons of CO2 emitted a year. 16, when they still didn't have PV, but they got a much better envelope of the building, they got down to 3.2. And then when we, as you can imagine, sort of like squeezing a cylinder, the farther you compress that cylinder, the harder it is, the more energy it takes. We're getting to that point where just getting from that 3.2 to the 2.2 was a lot of work. But by adding that very small PV system, that's what got you there. This is a slightly larger. The 3.1 is for the 2,700. The 2.8 is more of a 2,100 square foot. So anyway, if you go all electric, you're getting down, 1.1 with just a small PV system, and that PV system is sort of the same you have for a mixed fuel house. If you went for a PV system that was large enough to offset your entire electric load and all electric, you're down, under a ton, under a half a ton per year. So, we're putting the tools out there. We're trying to, get the strategies and the technology moving in a direction where we're going to have very low emission buildings going forward. So, in the future, once again, we're going to look at all things we learned in the residential, the low rise, see what can go for a high rise residential, what makes sense for non-res. Non-res, there's some things that are easier with the coincidence of load generation is there, where most of your load is while you're getting clean energy from PV systems. But you also have other challenges as far as roof space and just the amount of load. So we're going to do a similar approach we did to 16, and we're going to focus on envelope and efficiency measures first. And then once we've got the buildings as efficient as possible, then we'll look whether on-site generation is the cost-effective way to go forward. So I'm probably running short of time, so I'll go very quickly. Biggest thing we ask for is people to participate in our project process early. Right now, we're getting to the point where we're working with stakeholders, ideas to get an idea of what their list of wish list items are. So right around the fourth quarter of 19 is when we start doing workshops with our IOU partners, where they start talking about case studies that they've finished at that point, or at least drafted. So public participation in those workshops is great to get an idea of what people think of those ideas, but getting involved now and sort of saying, here's the ideas we think could make it your code, that's the most appropriate time. You can work with us, we can work with the IOUs throughout the state with their statewide utility programs. And the link that you have here gets you to our listserv. The advantage there is you see all the documents written out, but that's where you get notice of all the workshops, events where you have the opportunity to learn what we're doing and also put your comments in. So, sorry for that very quick run through of what we sort of did over the last 3 years, but I'll be around for any questions and then up on the stage as well.
Thank you, Chris. Our next speaker is Martha Brooke, and I can't talk and change slides at the same time, so be patient. Martha Brooke is the advisor to Commissioner Andrew McAllister, who is the commissioner responsible for energy efficiency at the Energy Commission. She has over 30 years at the CEC, and she's worked in demand forecasting, building efficiency standards, research and development of energy efficiency technology for residential and commercial buildings. And most recently, she's been working on strategies to scale energy efficiency in existing buildings. She's a professional engineer, and we're happy to have her with us today. She's going to give us a little bit of information about how the Energy Commission is looking at the future and of energy efficiency in buildings.
Good morning. I'm going to move this a little closer. Is that better? Great. Okay, let's see. So the policy direction for California is building decarbonization. So lots of things have happened just in the last year and a half, I'd say, on this topic. The Energy Commission participates in the Pacific Coast Collaborative. That's all West Coast states, the province of British Columbia, and the cities all across the western, the Pacific, ocean, basically, in the United States. And they collaborate on sustainability and codes and climate resiliency. And there is a new working group that's been active for about a year on thermal decarbonization. So low carbon, space heating and water heating in buildings, basically, and some processes as well. We had our first significant policy discussion for the state at the Energy Commission this summer as part of our 2018 Integrated Energy Policy Report. There's actually an active link there if you're able to get to it, if the slides are shared. There's a really robust and active stakeholder docket log that has all sides of the discussion, from don't make our houses and buildings less affordable to electrify everything now. So those are sort of the bookends of this discussion about building decarbonization. And then this summer, just kind of hovering around the Global Climate Action Summit last month, the governor signed into law new construction and replacement product incentives, SB 1477, which will be led by the Public Utility Commission. The Energy Commission has a responsibility now to meet statewide building decarbonization targets, 40% below 1990 levels in buildings by 2030. We're supposed to establish a plan for how the state will do that. And then the governor also signed SB 100, the 100% renewable portfolio standard. I hope we have questions in this panel about, well, what does it mean if you have 100% renewable grid? Why do you have to have PV on your roof? I think those are some good questions that we should talk about. And then finally, the Governor Brown's carbon neutrality executive order, basically to establish a goal to achieve economy-wide carbon neutrality by 2045. Just tiny little things like that. So, pretty exciting time. So just to kind of ground us on what that means if we're going to decarbonize our buildings, I don't expect you to see all the little text in the white boxes. Both of these charts are going to be in our policy report, which will be published, I think, within a month or two, maybe January, so look for that. So basically, the first chart to the left is the building contribution to emissions in the state. So it sort of combines natural gas use in buildings with electricity use in buildings, and it's basically a quarter of the pie, a quarter of the emissions in the state are produced in buildings. So it's a significant chunk of the greenhouse gas emission inventory. Now, the energy use used in buildings is basically split half and half between electricity and natural gas. So that means if we're going to, say, electrify buildings, well, we've got to replace half of the energy in buildings that is used today. So about half is gas, about half is electricity. The electricity grid is getting more and more clean, and also we begin to discuss about how to get renewable natural gas into the state and what we might want to do with that, where we would want to prioritize the use of renewable natural gas. Should it be buildings? Should it be transportation? Those are huge policy discussions that are just now getting queued up. And then to sort of carve out the biggest part of natural gas use in buildings is in residential homes and apartments and condos and townhomes. And most of that, like 80% of the gas used in homes is space heating and water heating. So if we have places to target, that's likely where we need to go. But then there's also a really interesting sort of market transformation topic about cooking. Because like I always use the expression, well, now we're cooking with gas, which means we're doing a great job here. We're finally getting on the right page. And people really have some pretty strong opinions about what's better to cook with. And some of the things that we need to talk about in the session about emerging technologies is what are the best ways to cook, both commercially and residentially, and can be done with things that are low carbon. So this is a chart I love to show now because it's sort of like what, as policymakers, we have to think about. And what this chart shows is every hour of the year in 2030, so looking forward a few years, if we met 100% renewable, but if we met our current state law, which is 50% by 2030 renewable electricity, this is the emission intensity of electricity compared to the emission intensity of natural gas. So everywhere it's pink or red, electricity is actually less green than using gas in the building. Everywhere where it's green or dark green, electricity is a cleaner fuel to use at the building location. So this is just a good illustration of our challenge, because it's not a slam dunk. It's not always better to use one fuel or the other. We need to be very thoughtful about when we use electricity and to use it in the green hours and not in the red hours, and to really think hard about when's the right time to use natural gas in buildings and when we should switch to electricity. Future building standards. We are now beginning discussions for the 2022 building standards, and we're talking with early stakeholders, not everybody, but our key partners and utilities and our own staff about looking at an energy metric that aligns with emission reductions applied to all fuel types. Right now we use energy costs. The time-dependent valuation of energy is an energy cost metric, and that does a great job of valuing reductions at times of high electricity prices. It's really not a great metric when we're trying to make natural gas and electricity compete at the same time in a building design if we're valuing emission reductions, because gas is a little cheaper than electricity. So we don't want to lose that demand flexibility part of our current energy metric for code, and that's demand flexibility, using electricity at the right time of the hours of the day. And so we think we need to do both. We need to have an energy metric that is aligned with carbon, and we need to have a demand flexibility metric for electricity. And then because of another thing that comes along with building decarbonization is what we heard this morning about climate resiliency. And the whole reason we're doing this is because of climate change. And so we have to begin to, in our building standards, really emphasize strong, resilient building envelopes that are going to last 50 to 100 years. So in the building code and in the way that we implement it, we have to be careful that we prioritize and protect the building envelope. Right now, in our performance trade-off approach, we really don't care if we trade away on envelope measure for an HVAC measure. It's treated the same. They're treated the same, even though the systems, the mechanical systems, are likely not to live as long and last as long and be persistent as the building envelope. And the other issue is that for climate resiliency, when you might actually have more times in the state where you lose power from one extreme event or another, the building envelope is what's going to keep people safe and healthy. And so we really need to do a good job really prioritizing the efficiency and the resiliency of building envelopes. And then finally, we really think that cities have a key role to play in our building decarbonization goals. There are several cities right now that are discussing building decarbonization local energy codes, and we're trying to help them support their climate action planning by adopting local ordinances that really support low carbon buildings. And that's all I have.
Thank you, Martha. Next, we have touchscreens. Right, Anna Speedster has a master's in architecture. She's an international expert in sustainable energy and ZNE homes and communities. She's the author of Energy Free: Homes for a Small Planet. She was a juror on the 2015 Solar Decathlon at the U.S. Department of Energy, and she's an advisor, or rather a director of the ZNE Coalition. And she's going to add some real-world perspective to our discussion of codes and standards, and we're very grateful to have her here today. Thank you, Anne, for coming.
Thank you, David. So I always find it entertaining to be invited to speak on technologies because I can talk about them a little bit, but I invariably divert into non-technology questions. So that's a little foreshadowing of what's to come. As David mentioned, I'm here, I'm sort of the real world person. I'm kind of a half real world person. person. So I'm a consultant. I'm not actually a practitioner, but I work with practitioner teams. I've worked on a number of zero energy pilot demonstration projects as well as research projects throughout the state and nationally and internationally. So I have the opportunity to watch what's happening with practitioners in the field quite a lot and hear what they have to say about their challenges and experiences. So what I'm going to do today is talk a little bit about a project that I'm currently working on, and this is actually sort of I'm going to call this a phase 2. There have been 2 project teams. The first one I worked on was for PG&E. We worked on this project for Habitat for Humanity in San Joaquin Valley for a couple of years, and we had one ZNE demonstration home there, and then phase 2 is a new project that's CEC funded, and it's with Gas Technology Institute as the lead. The second phase is building on the first phase. So I'm going to talk a little bit about both here, and then I'm going to segue into some of the larger concerns that are highlighted both by this project and by some others. So, first of all, this project, the current GTI project, had the goal of really looking at an all-electric home versus a mixed-fuel home. And the homes have in common all of the basic stuff that you would expect. You know, they're framed efficiently, they have tight, well-sealed enclosures, compact HVAC and water heating in conditioned space, and so on and so forth. What I will say though, it's all the stuff you would expect, but really done to a rather phenomenally high quality degree. So, and the reason for all that is George. George Kurtzen has become something of a real rising star in this arena. He's a very senior builder, has a really very, very long bio in terms of his building experience, and particularly with a lens on efficiency. So George approaches a building project like no one else I've ever met and finds efficiencies that no one had any idea were there. So any idea you have, he's going to have 3 better, which makes it entertaining to work as a consultant with him, because he'll say, hey George, have you thought about this? Well, yeah, but. So he claims to have learned something from some of us in the consulting team. I think it's more the other way around. So that's about George. So now about the technologies. I do have a little bit to say about that. This is the little table of what we think we're going to be doing these 2 houses, which by the way just broke ground. And so presumably will be built and completed sometime over the next half-year period. Now, one of the really interesting things about this project is because we are actually dealing with emerging technologies, we're not entirely sure what we're going to be using in these homes, because our team is going to wait to make that, pull the trigger on the purchase decision at the last possible moment so that we can be working with the best available information in that moment. But this is what it looks like right now. So again, we've got the all-electric house with a 3/4 ton ducted mini split system, which has become the go-to solution of choice for many folks on our team for a variety of reasons. And there's kind of a behind-the-scenes, I'm going to call it a one-downsmanship game going on right now within this little community of energy geeks, residential energy geeks, and that is how small a heating and cooling system can you use and still meet comfort parameters. And we've got some pretty fun statistics on that on the phase 1 project report, which I didn't include a link to, but if you guys wanted it, I'll be happy to send it to you. And on the other hand, a combined hydronic system. And again, nothing terribly surprising here, but there you have, there's the technology story, folks. That's exciting, isn't it? Okay, so I'm going to talk a little bit here about what happened in phase 1 and how this is a setup for phase 2. So the EUI was a little bit higher than, say, the exemplar in the Arab baseline study of a few years ago, which you guys will all remember. But when it's normalized on a kind of a per occupant basis, it's actually better because this is a smaller home than the exemplar that was used. So there's metrics. I was talking to Charles earlier about energy metrics. That's a fun conversation. We won't go there now. But at any rate, we looked at the metrics a little bit differently. They came reasonably close to zero energy operation. There were a couple of confounding factors there, like an aquarium and I believe it was a heated something or other, or a crazy television display, Christmas decorations. Anyway, there are a few plug loads that went into this home that the family had no notion were going to affect their electric usage so dramatically. And when the results started to come in, George went in and educated them, and they have since brought those loads down. But anyway, that was one thing that was pretty off base from the modeling. The other one, or the other major opportunity, so the largest load and largest opportunity to reduce we see is in water heating. We kind of knew that going in because the water heater they used was kind of minimal efficiency. We really wanted them to go to a much higher efficiency unit, but Habitat being Habitat, they were committed to a different budget. On the phase 2 project, because this is particularly a compare and contrast exercise, we have money for them for the technology so that we are able to actually look at results of higher performing equipment. So that's something that we're looking forward to. But I think some of the big takeaways here are due primarily to George's ingenuity. Reduce infiltration 2/3, reduce lumber by half, and by the way, without compromising structural performance. They saved $3,000, almost $3,000 as compared to the prior model. This really sort of flies in the face of convention, and one of my favorite things to do is to say, we're asking the wrong questions when we do our research. And the most wrong question we ask is, how much extra will it cost to achieve zero net energy? I know Christopher doesn't like net, so we'll ignore the net. But we all know what we're talking about. A highly efficient home with or without PV, something that's capable of being zero something in some framework. At any rate, the question really should be, what do we have to do differently to achieve zero on budget? And this is what George has done. And he's basically said, okay, well, I can make all these trade-offs. I'm going to find those efficiencies nobody else is looking for because that can pay for the improvements in performance that I want to make. So with that, they've been tremendously successful, and George is a rock star. He is also a unicorn. They're very rare, in case you didn't know that. So in the real world, what we have is a bunch of cats. And herding them is a remarkable challenge. So even though we know these results are achievable, and it has actually been done, it's not just theoretical, getting other cats to do as George has done is a real challenge, to put it mildly. So what are those challenges? They are numerous. I've picked out 4 to just run through really quickly. This one, the race to the bottom. I love this cartoon. It kind of says it all. The race to the bottom really kind of is suicidal, right? This drives me crazy, and it was particularly bad a decade ago where businesses were price cutting ostensibly to stay in business. But what they were doing is they were creating a situation where they were engineering their own demise because they cut prices to the point where they actually weren't sustaining their businesses. So this hurts everybody. And it really shows up in the residential building industry and, in fact, our entire culture, because most consumers or homeowners have been acculturated to the notion that you get 3 bids and you go with the low bid. They think they're all getting the same thing. This is a horrible, horrible, horrible misconception. And there aren't really great solutions to it, but it's really fed. I think, a colleague of mine many years ago said something I think was a really important statement, which is there's very few people who will get up in the morning and say to themselves, I'm going to go out there and do the worst possible job I can do today because it's going to save somebody money. Like, no, that's not why people go to work. They really do want to do their best, but we're not providing training on proper installation or decisions, design decisions and construction decisions, and we are not giving them enough time. And that is one of the worst artifacts of low bid, is there's not enough time to do a good job, and that means they're not even meeting manufacturer's specifications. And by the way, compliance isn't really terrific either, so we're not doing a really good job of code enforcement. So what are the solutions? Well, there's a challenge. I'm not sure that there is a technology fix for it, but I will put out there that if we can come up with more products that can be installed absolutely goof-proof, that would be a step in the right direction, because nobody should assume their product is going to be installed correctly unless they put it in the hands of, I don't know, a few subcontractors under low bid pressure, or maybe a few 9-year-olds, and said, try and install this correctly and see what happens. So there's challenge number one. Challenge number two, for all electric homes in particular, fear of the known, or what we think is known. And Martha mentioned induction cooking, and this is really, really a big one. So even though space heating and water heating aren't the biggest parts of the pie, we really aren't going to succeed in selling the notion of an electric home being a desirable thing unless we can get over the electric cooking hurdle. So my first suggestion is, hey, let's stop calling it electric cooking, because that's got baggage. And you know what? Your gas stove is plugged into an electric outlet too. So let's call it magnetic. Huh? How about that? That'd be pretty fun. So that sounds really groovy and new age. And so we're just, we don't have enough Madison Avenue savvy in this industry. We need to co-opt that. Heat pump water heaters, we have space and ventilation needs in our retrofits. And of course, everybody kind of knows about the duct curve effects and panel capacity. So this is a significant one if we are looking at electrification in existing buildings. So, and there's been a really active dialogue among an inner circle of geeks lately about, what is that? Is 200 amps enough, or are you going to have to go to 400? If you need 207, you need to go to a 400 amp panel. So we need to start working on these things. There are some potential technology solutions here. Again, marketing, that's not a technology solution, but marketing and technology often go hand in hand, so I'm going to encourage all the tech people to be talking to their marketing people. Obviously, we want to be looking at more sophisticated demand control so that we can be more grid responsive, and then lower amperage equipment to serve the same purposes along with load balancing. Okay. Challenge number 3, zoom, here we go. So on the mixed fuel side of things, we've got some regulatory and rate structures that disincentivize zero energy by whatever flavor. I'm avoiding saying net, Chris. You feeling better? The N's in there, but we'll just ignore it. We can't right now offset natural gas use with solar, or at least only some really crazy energy philanthropists can do that. As a consequence, decarbonization of the mixed fuel housing stock is very problematic. So what do we need here? A couple things that aren't, again, technology per se, but maybe there's some technology bits that can help us bridge these gaps, and accounting mechanisms, which I think technology can really help us with. But again, not strictly technology arena. Okay, number 4, and there are certainly more, but this is my last one for today to just be provocative. So the state goals say we need more renewables, but for a variety of reasons, we're seeing brakes put on renewables, again, because of the duct curve, and of course the equity issue, as Martha said. If we're going to have a 100% renewable portfolio standard, should we really be pushing solar at the individual building level, where it costs quite a lot more on a per unit production basis than it does in utility scale things? And then, of course, in denser cities, I was talking to one of the folks who works for City and County of San Francisco, and they've done a study and said, well, what if we covered every bit of solar suitable roof space in San Francisco, how much of our load could we need? Anybody want to guess what the number is? And if you know, you don't get to guess. Guesses? Okay, you're all timid. 10%. Pretty sobering thought. So, yeah, we actually do need to be putting solar where we can, and that means we need to solve all these other problems. So we need storage at all kinds of scales and demand controls to kind of go with and really enable all these things. We also need to get the community solar thing going, right? And not let Minnesota be way ahead of us in Colorado. And have I mentioned accounting systems? Yes, I think I have, so let's get that going too. And then of course higher PV efficiencies would be marvelous, and I think we will get them, and we will get more vertical PV solutions. And I think there's going to be some really interesting things about the vehicle to home. I know there's a lot of controversy about that, but there are definitely some balancing opportunities there, and as we go more towards electrification of the transportation sector, that's an inevitable play that we want to be looking at. So that is it for the moment.
Thank you, Ann. That was excellent. And now we move to the Q&A part of our session. And I'm going to start with a question for the panelists. And all right. One of the problems that the building standards are facing and ZNE building direction is facing is the supply curve, especially here in California. There are changes in the supply curve where energy is inexpensive in the afternoon, and during the summers there's even over-generation and negative prices, primarily due to the amount of solar PV that's on the system. And at the same time, the building standards are based on a cost-effectiveness metric that is changing, but still based on the idea that the highest costs are in the afternoon, especially in the summer, the way they were 10 or 12 years ago. And so, if cost-effectiveness is an issue for both of these policy goals, the standards and ZNE, and to the extent they overlap, the question is, how do we address the fact that the supply curve is changing and the cost structure is changing, and how do we justify or even count the savings that we can see from efficiency investments in a way that makes sense given our system and given the potential for future dynamic and other kinds of tariffs, and even the future of time of use tariffs for the investor-owned utility customers starting next year. So that's a big question wrapped into a small question, and I'd like to get started on that. And I'll remind everyone that when you do want to ask questions to the panel, that there'll be a mic runner to run around, and he's right here, and the mic will be available to you. So, who'd like to go first?
Is this working? Okay, so I guess I first have to say that this is my personal opinion. I don't think I'm necessarily representing the state of California or the Energy Commission, but nor do I think I'm trying so Christopher can do the counterpoint to this, and we'll see where we end up. So I think when I think about all the things you said, David, about changing supply curves and time of use rates that are going to change over time, I think it's really important to think about what a statewide building design and construction standard is and what it is not. And I think that we often think, well, here we have a stick, so let's hit everything possible we can hit with it because it's a pretty big stick. And I think that instead we should focus on what does standards build a statewide building standard do well, and really focus it to do as absolutely good as possible. So, take my example of the building envelope. We need to design our building standards so that the energy use in these buildings is known, or at least known with some level of probability over a range of costs and over a range of future rates and over a range of future supply options. But we're fooling ourselves if we think that we're going to design a statewide standard that for buildings that are going to be built and last for 50 to 100 years, and that we're always going to pick the optimal solution, energy cost-wise, for the occupants of those buildings. So I think that there's only so much you can do in a building standard, and I think energy cost is the hardest thing to get right. And I think the other thing I would say is that the other part of our obligation for our building code given to us by the state law, long-standing state law, is to balance energy costs for consumers with environmental protections. And so that's the balance I think that we need to meet more and more with a carbon-aligned energy metrics for the code. But we also have to make sure that it's cost-effective to consumers over a broad range of possible futures.
I'm not sure how much of a counterpoint, because I tend to agree with a lot of that. Basically, I'm just very happy that we do this on a 3-year cycle, not like a 10-year cycle, because then the tea leaves get a little murky. Basically, I agree with Martha that we have to focus on the building envelope because of the durability and the duration of that. And there are a lot of great ideas we can have that they look cost effective now, but we don't know what's going to change. And because of our sort of mandate of what we're supposed to do, I can only really look at what the very easily predictable, justifiable rates are that the customer is going to pay, not what I think 3 or 4 other things in combination might cumulatively do to rates 10 years from now. And then I say, well, if that all happens, then I can actually make them do this. Or I can justify that as being cost effective. I have to look at what's very readily available, both technology and the picture of where the rates are going. So we try to focus on things that are conservative so that we don't put people at risk. But as Martha says, we spend a great deal of time talking to a huge number of stakeholders. We had 100+ stakeholders with 3,000 comments for our recent standards, and we talked to all those people because we want to understand all the unintended consequences environmentally, economically, and when we're looking at a certain standard, we want to make sure that we understand that not just the, as I said, not just the cost to that consumer, not just the environmental cost, but what are all the unintended consequences of that decision that may have other economic costs beyond the standards and other environmental impacts beyond the standards. So we try to keep all of those balls sort of in the air when we're thinking about these things. So I mean, it's not an easy answer because it's not an easy question, which you're smirking because you understand how hard that question is. But and that's about all I have on that. I'll pass it up to Ann to add a little bit.
Rather than fighting the switch. What they said, pretty much. I guess a couple of things I want to add is, from my position in the building industry, I would say we, meaning, my people, we know what a good house looks like. It's not rocket science. So what we really need is for the regulatory forces to work with us and not against us. And I think there are a couple of notable issues, not necessarily again in the realm of technology, but I think that Warren Alquist has been treated like a sacred cow and it needs to be updated. Flash bulletin here. So, and I also think that the cost effectiveness test is needed reform. So I don't think the real challenge is in understanding how to build good homes. The real challenge is the other way around. So we shouldn't be turning ourselves into pretzels to try and understand the cost component. We get that. We should be looking at the regulatory mechanisms and how they do or do not support what those goals are, which are quite well understood. I think we also have some challenges in the fact that when we're basing, for example, compliance with the building standards on time-dependent valuation and those supply forces are changing what that means from day to day, minute to minute, year to year, then first of all, we don't even have a way to determine after a period of operation if we've even complied retroactively with that standard. We're only able to comply with it in a hypothetical way based on a simulation. But secondly, it's a moving target. And so your home that might be in perfect compliance today, at some point in the future, might no longer be, even if it did perform as modeled, even if one could verify that in operation. So we've got a number of challenges between reality, regulation and theory. So again, some of which may be addressed by technology, others perhaps not.
All right, thank you. I had some follow-up questions, but you guys actually skipped all the way through those, and so that's why I was smirking, Chris, is that I was happy that the discussion was sort of going in the direction I was hoping it would go. And with that, I'd like to open it to the audience. Does anyone have any questions? Just over here.
Hi, my question is for Martha. With government
Please identify yourself and then ask your question.
Sorry. Thank you for your time. My name is Orly. And I wanted to hear, with what we hear from Governor Brown about the electrification of California, with putting that together with the comparison that you had between the gas usage and electricity usage, where do you see the vision and the results of your comparison playing in the real world?
Mike's not on, Martha.
Is this one working? Okay. So at risk of getting too far out ahead of my boss and the governor, I would say it's hard for me to think of a solution that isn't a strong push to electrify the end uses that we can electrify, that we have current and emerging technologies like heat pump water heaters. And that's because especially things like a water heater that has a storage of thermal mass capability, so you can heat it at one time and use it at a different time. You can ride through those red parts of that chart, right, and still do that with electricity. So I think there's a big future in using green electricity at the right times of the day. I do think, though, with a bigger, beyond what we're talking about now, which is residential, in commercial and industrial, I think there's critical end uses that use gas now that we don't have effective, both technology-wise and cost-wise, replacements for that use electricity. And I think that's our big challenge is how do those critical end uses in the built environment compete with transportation or power plants for renewable natural gas, which we know can grow, but does have physical limits, unless we're talking about opening up the horizons of technology and growing crops for renewable gas, right, which is way further out than our policy goals that the governor put in place. So our policy report, which will come out in a couple months, does basically explain the potential benefits of electrification, and then some of the issues which we've talked about today: consumer acceptance, costs, technology readiness, those kinds of things. I hope I answered your question.
All right. Additional questions?
Can you hear me? So this question is, I think, for the panel in general, so you can choose who answers this first, but mainly from a policy perspective, I'm wondering how much in that vision that we see for 2030, are we considering the today opportunity of safety. So Martha, you spoke of the building envelope being one critical piece when you decide performance trade-offs. But I think that's only the start of the idea. Today, when the wildfires are so real in California, if we are really starting to think about passive solar design, say in residential or even commercial, we may need to be looking at fundamentally different construction technologies. Maybe wood frame is no longer the correct technology. We have in the past managed to tap into some earthquake design and bring that into the energy sphere. So do we have a vision for where we can again join hands with the safety community and maybe hit two birds with one stone and create a more resilient design? Part two of that question is, does your 2030 graph that you showed take into account that in those night hours, we could essentially be having no need for, say, heating because our building's envelope would be thick enough to not need that?
Is this working? I'm going to answer the second one, and then I'm going to ask Christopher to talk a teens about the first one, and obviously you've got some stuff she does. So that chart, I think just to clarify, it has nothing to do with the profile of demand in buildings. So, right, like when you need water heating or when you need space heating, it's just looking at the emission intensity of the fuels available to buildings or commonly used in buildings, right? So absolutely, that's why, to answer the way I answered the last question is, you might not need to use any energy for very little when that chart looked red, right? So when gas was lower emission intensity than electricity. And absolutely, if we do a better job with thermal efficiency of the envelope and passive, pre-cooling and all those other strategies, you're going to be able to coast through a lot of those red hours, in my opinion. And I think the Habitat for Humanity homes, they do a lot of passive design where they are really reducing the loads and when you need that heating and cooling because there's so much thermal mass in the building. On the safety issue, I'd say one thing you should know is that what I want Christopher to talk a little bit about is we do work with the state fire marshal on our building code, and that's just an example where we could do a lot more to address the safety of the built environment.
Yeah, you're referring to safety. Yeah, the other thing on the chart of intensity. One thing that, as Martha mentioned, that the building standards are just a little part of the overall need to address GHG, the carbon issues, energy issues in California. So we try to do the best we can there, but also keep in mind of how we can integrate our solutions with that in the transportation section. Do you do things in the CEQA realm with developing large communities? We just want to do what we can in ours without overstepping it. But also remember that people talk about they want to bring EV charging into the building. How do we deal with that? How does the grid deal with that? If you added another load when the grid normally would be cooling off on the residential side, when it didn't have a large load, it's now you're adding a new one. So that's the kind of stuff we have to think sort of beyond our normal, here's what the building is, to what are all the other things that could affect the building, what are all the other things that could affect the grid, and what is our cumulative impact of that. So that's just something to keep in the back of our minds. As Martha said, we do a lot of work very proactively with the fire marshal. We've also talked to a lot of people post Sonoma fires and other fires in California on to rebuilding the resiliency of the system, the resiliency of the buildings. We come back to the cost effectiveness. It'd be great, we just throw insulated concrete foam houses out there, and they might not burn well. You just have to deal with the toxic issues of foam, but well, that's another issue we're working with the fire marshal about. But it has to be cost effective, and that is where if consumers decide that they want metal roofs, they want fire-proof houses or fire-resistant houses, that has to be something that people decide that they want to push builders, and builders can find ways of cost effectively doing that. We will provide, as always, pathways in the code where we do it as a performance base where people can make good choices, and we'll try to make sure we get rid of barriers to it. But the difference between traditional and those very sort of disaster-proof houses can be magnitudes of cost that it's not always appropriate to put into code. So we will continue to work on making the houses better. But as I saw in Sonoma, it's like even houses that were well built, some have really high-end sprinkler systems. The houses were so close together that just the thermal or the temperature of the house next to burning, just spread it, not directly, but just through the air. So it's just, the solutions are going to be very complicated if you want to build a disaster-proof community. It's like, how far apart are the houses? Do you bury the infrastructure? What do you do? What do the houses? Do you bury the whole house? Be very disaster-proof and energy efficient, but it might be slightly dark. So I'll pass it over to Ann and see what you can add.
I'm going to take a totally different tack here. There are many questions embedded within your question. It's been challenging my train of thought to hold these threads. So first thing I want to comment on is your use of the term passive solar. I would like to banish that term from use because passive solar has a long history, a 40-year plus history, and what it has meant historically was let the sun in when you want to heat and keep it out when you want to cool. The problem with that is with our much better insulated and airtight homes that we're building now, it is extraordinarily easy to overheat. So we're still using passive design principles, that is using non-mechanical means to assure comfort. But the notion of letting that sun in full blaze, particularly a problem this time of year. I live in Pacifica, it's a coastal climate like this is, and even in our humble climate where we have effectively 0 cooling degree days, it is possible to overheat even in a house that's not tremendously well insulated and air sealed. So that's a little bit of an aside, but I think a significant concept that needs to be really recalibrated within the industry. A couple of other thoughts. None of the information that's been presented so far addresses the embodied carbon in new construction. And this is something I think is hugely important. We basically, from a carbon perspective, climate change perspective, we need to stop building. So yeah, when we build new, we need to do it really, really well. But honestly, we should be building, retrofitting and rehabilitating as much existing building stock as possible. Of course, in areas that have been burned out, we have to rebuild. What do we do? Yes, we want it to be safe. And I think we want to spend our money well. Again, I'm going to say, if you don't like the word net, I'm starting to really not like cost effective, because one of the real problems with that is there is always a different way to spend the money in any budget. You show me any off-the-rack production home plan, and I can find $15,000 in that in a heartbeat. It is not hard. Start with the roof. The roofs are ridiculous.
Hey, Ann, sorry to interrupt.
Oh, come on, I'm just going.
This is really great. We do need to start to break for lunch, and we can keep the conversation going, but I just want to give you guys a sort of a 1-minute warning if we can wrap it up. Thank you.
Minute warning, okay, good, so I don't have to completely stop and rant. Okay, so roofs, if we start at the roof and work our way down, we can find a lot of money to save. We can improve solar opportunity on homes, we can improve thermal performance. We can reduce risk from ember intrusion by having less elaborate roofs and less linear foot of eave to catch embers. There's a lot we can do. The Institute for Business and Home Safety, Insurance Institute for Business and Home Safety has done a lot looking at wood frame. I also want to say let's not move away from wood frame construction because it's very low in embodied carbon. Insulated concrete forms are a disaster from a carbon and embodied carbon perspective. When you look at the embodied carbon profile of a home across, let's say, a 50 to 100-year lifespan, you might say, well, the embodied carbon is a really small fraction. When we have a 15 to 20 years time frame in which to turn around the engine of climate change, and you narrow that lens and you look at embodied versus operating carbon in new constructions, embodied carbon dwarfs operating carbon for new buildings. So we need to be very, very, very concerned with that part of the equation. I'll just leave it there.
All right, thank you very much. Let's have a round of applause. Thank you.
How are you? See you, man.